Welcome back to this video series of C++ programming. This is the lecture 27 of this video series. Today we are going to discuss about a pure virtual functions in C++ programming. Pure virtual function is an extension of a virtual function in C++ and it comes under a runtime polymorphism. Let's discuss some of the important points about pure virtual function. When a virtual function is not redefined by a derived class, the version defined in the base class will be used. So as we saw in the previous lecture of virtual functions, if we create a if you create a virtual function in the base class and if you not define the same or if you not overridden the same function in the derived class, the function which is present in the base class will be used. When you create an object of the derived class and trying to access the virtual function through that object, the virtual function one present in the base class will be called. So you don't have to specify or you don't have to redefine the virtual function in the derived classes. However, in many situations, there can be a no meaningful definition of virtual function within the base class. For example, the base class may not be able to define an object sufficiently to allow base class virtual functions to be created. Further, in some situations, you will want to ensure that all the derived classes override a virtual function. So in some of the scenarios where you want that all the derived classes must define the virtual function, because that virtual function will have to execute some different functionality based on the requirements of the each derived classes. In these situations, the pure virtual functions are very useful. Let's understand the syntax of this pure virtual function. Pure virtual function is a virtual function that has a no definition within the base class. So there is a no definition. To declare a pure virtual function, you have to use this form. There is a no definition, but there is a declaration. So this pure virtual function is declared within a base class. And this declaration syntax is like this. So you have to start with this virtual keyword, then the type of that function, name of the function, parameter list, and then after this, these two important things, this equal to and a zero signs. This makes a pure virtual function. Now this is just a declaration and this declaration will be present in the base class. And then when a virtual function is made pure, all the derived classes must provide its own definition. If the derived class fails to override the pure virtual function, a compile time error will result. That means when you make a pure virtual function, all the derived classes must provide the redefinition or definition of this same virtual functions, and if you fail to do so, compiler will throw an error. Let's understand how we can create a virtual function with the help of an example. First, we'll create some classes. We'll create one class called as a base, and inside this, we'll create a one pure virtual function. So how to create a pure virtual function? You have to specify this virtual keyword, type of that function, name of the function, the parameters, in this case no parameters, then this equal to sign and this 0. Now this v function becomes a pure virtual function and it is defined in the sub declare in this base class. We'll create two more classes. We'll call this as a derived one, and this is derived from the base class. And here, since we are using the pure virtual function as we discussed, we must provide the definition of the same function, and you don't have to specify virtual keyword again. Here we'll print this. And also in the and this will call as a derived 2, which is derived from the derived 1 class, and we'll provide one more definition of the same virtual function. And inside this main function we'll create a object for this derived 1 and derived classes. So what we did is we created first a virtual function, pure virtual function in the base class. Then we provided the definitions for these virtual functions in both the derived1 and derived2 classes. As it is expected by the compiler, you must override both this virtual function in all the derived classes. And here, now with the help of this objects, we can access the virtual functions. Okay, we'll first compile our program and we'll see whether it is compiling successfully. If it's compiled successfully, let's run it. And now it has printed these two strings here, a derived1 virtual function and a derived2 virtual function. All right, so now as we discussed before, all the derived classes must provide this definition of the virtual functions. Now let's comment out this code here, so that now we're removing this definition of this virtual function from one of the derived classes. Now in the situation where this function is not a pure virtual, that means if you remove this part here, then compiler in this case will not throw any error. So the compiler will accept this definition, because as we saw, we can, if you don't specify any if you don't override this virtual function in the derived classes, the one present in the base class will be used, but in pure virtual functions it is not true. So now let's compile the program and let's see what does it outputs. So as expected, it has thrown two errors. First one is derived1 cannot instantiate abstract class, and base virtual function not accessible because derived1 uses a private to inherit from the base. So we'll see this the more about this errors, why it is not giving this abstract class error. What is the meaning of abstract class in shortly? But for now we'll okay, for now you have understood that you have to provide this definition of this virtual functions in all the derived classes, otherwise the compiler will throw an error. Now let's understand about this abstract class. We saw there was an error related with the abstract class. So what is abstract class? A class that contains at least one pure virtual function is said to be abstract. So the class which has at least one pure function, pure virtual function, is called as an abstract. And because an abstract class contains one or more functions for which there is no definition, that is a pure virtual function, no object of an abstract class may be created. You cannot create an object of an abstract class. Instead, an abstract class constitutes an incomplete type that is used the foundation for the derived class. It is like an incomplete type. You can't create an object of that abstract class. Second point, although you cannot create an object of an abstract class, you can create a pointers and references to an abstract class. This allows abstract class to support a runtime polymorphism, which relies upon the base class pointer and references to select the proper virtual function. You can still create a pointer to the abstract classes objects, and then with the runtime, I mean by using those pointers, you can achieve the runtime polymorphism. So we'll see these 2 points again with this an example. So here we'll create a pointer to a base class, and call this as a pointer to base class pb. Now with this assign the address of the derived class. We'll point this derived class object to this base class pointer. As we saw earlier, even though we cannot create an object of the base classes or abstract classes which has a pure virtual function, we can create a pointer to those base classes. So we have created here pointer, and we are assigning the address of this derived class d1 to this base class pointer. Now with this base class, we can access the virtual functions or the any other member functions present in those derived classes. Now let's compile this program and run it. So it is outputting the value as derived string as a derived virtual function. So this is how the runtime polymorphism is achieved. Here when we are assigning the address of a D1, this is happening during the runtime by evaluating the virtual function table. And this the version of a virtual function to be called is based or is decided based on the type of this derived object. So if you specify here D2, the virtual function present in this derived class 2, derived 2 will be called. And if you specifying the D1 here, the virtual function from the derived 1 class will be called. So this is how the runtime polymorphism is achieved even with the pure virtual functions. If you are trying to create an object of the base class here, compiler will give an error saying object of the abstract class base is not allowed because the function is a pure function. So you cannot create an object of this abstract classes or the classes which has at least one pure virtual function. Now let's discuss this one of the two important points that are frequently talked when you deal with the pure virtual function or the virtual functions, that is early binding versus a late binding. So early binding and late binding is related with the runtime polymorphism. So first, let's understand what is early binding. So early binding refers to events that occurs during the compilation time. Early binding means that an object and a function's call are bound during the compilation, and that means it's like events which occurs during the compile time are called as an early binding. The main advantage to use early binding is efficiency because all information necessary to call the function is determined during the compile time, and that's why the functions are very fast. When during the execution there is no additional things to be taken care when as compared to other random polymorphism. So that is the speed and the efficiency is the advantage of early binding. However, late binding refers to function calls that are not resolved until the runtime. So example is we saw in this case of a virtual function where we are using the pointers to a base class, the pointers of a base class, and based on the derived type objects, the virtual function present in that particular derived class will be called. So that is part of a late binding, and that decision is happening during the runtime or the functions call are not resolved until the runtime. And because in most cases this cannot be determined at compile time, the object and functions are not linked until the runtime. So that linking of those functions is not done until the runtime. The main advantage of late binding is the flexibility. So you can provide your program has better flexibility, which functions of the which virtual functions to be called is determined during the runtime and not during the compile time. This provides the more flexibility. However, in terms of in sacrification of the efficiency, the late binding creates a it is slow as compared to a early binding. So this is all about the pure virtual functions. So I hope you have understood this the concepts we talked about the pure virtual functions. So for now, thanks for watching the video and stay tuned for the upcoming video.